will give the floor to Ghazaleh. You're already a presenter. Yes, and can you explain the different approach from SEAFAR for Pioneers projects as well? Thank you.
Yes, sure. Hello, everyone. Good morning. It's our pleasure to actually be here and presenting about CFAR and our project Pioneers. Thank you very much, Alice Thomas, for our invitation. So, I hope you see the screens. First of all, who is CFAR? So CFAR is a Belgian Antwerp-based technology and operations company. We are pioneer in remote controlled and remote assisted inland navigation. We operate the remote operation centers with real vessels under commercial pressure. So I am Ghazaleh, R&D project manager at CFAR, and today I am presenting on behalf of Nancy as well. Ms. Nancy Schijven is our strategic business director. What we do is actually enabling vessels to be operated remotely and more efficiently. We combine technology, trained operators, and also operational procedures, and we support the ship owners in addressing crew shortages and cost pressure. So up to today, we have actually operated more than 25,000 hours in real world conditions. So far, we have equipped more than 55 vessels, which represents 500 ships in owner fleets. And also, we have been active across multiple European waterways, including Rhine corridor. What is actually our vision? So our vision is to centralize and optimize the workforce via the remote operations. If we look at the Green Deal ambition, we can see that there is a need of 8,000 vessels by the year 2035, and this is while the available number of human resources is reducing every year. So we actually want to bridge this gap with CFAR technology, and we want to enhance the competitiveness of the waterborne transport, reduce the operational costs via onboard crew reduction, and strengthen the business case to increase the green investment. Finally, we want to centralize the operators and increase efficiency and safety. So, although CFAR is a technology platform provider, we have seen that over the past 7 years, the technology itself might not be the biggest challenge there. Although the technology will keep on renewing and becoming more integrated with artificial intelligence. So why is that? Actually, the technology needs to be also accepted by the regulation authorities and also needs to be adopted by people. In our R&D environment, we are testing technology. That is the key. But in order to scale it and make it applicable on a larger scale, we have a lot of work to do in regulations and also human machine and human interfaces. So here you can see a dashboard showing different vessels equipped by CFAR. So at present, we have 55 vessels which are equipped with CFAR technology. CFAR is at the moment mainly active in inland shipping. Actually, we will revert to this topic a bit later because although inland waterway transport is the core of what we aim at, we can do more than that. With the crowded roads and also rails, though, we aimed at inland waterway transport because the policymakers want to achieve a model shift also to inland waterways, and we think it is being a niche market. For now, this is where we can add the most value. On the waterway, there still is a space which can be used for transportation. Getting the goods from across the ocean to the hinterland of Europe, it has been like that for ages, and we think this means of transport is of major importance, although not well known by a lot of freighters. And the inland waterways is facing their challenges can be an added value to the logistics. So, as I stated before, we do face some regulatory challenges in order to make our work scalable. We do not consider ourselves as research executioner. We have a commercial operations model where we sail remotely the vessels from our customer side. The real challenge is how do we ensure that, besides working technology, laws and regulations to be on the same page across borders. From the Middle Ages, we have rules and regulations on shipping, and since over 200 years, we have formalized rules, like in the CCNR. So in the CCNR, we have harmonized, in the CCNR, we actually have harmonized rules across 5 countries, but in different areas like harbors or local fairways, different rules apply. So what they have all in common is that they are built around on-board presence. So it also implies that there are no rules yet for a shore control center or a remote operation center. And besides that, there is not any clear liability models in place now. So this is the journey that SEAFAR is embarked on, with the authorities being national, harbor, local, and also CCNR. The other important aspect, which does not make scaling easy, is that people need to trust, adapt to, and also use the technology, and they also need to do so in the right way. It makes training very important, but here we do again face the century-long history of sailing that does not always help in adapting new operations model. So the boatsmen of today already differ and require different skills than the boatsmen of yesterday. But think of the boatsmen of tomorrow or in 10 years. They also require different skill sets to gain situational awareness, decision making, and also ensure that goods travel safely from A to B. So the interaction between people and the interactions between technology and people will be a topic for years of investigation to come. So not a reason to not change though, because while technology is there, let's start and make the shift to the technology behind CFAR. But what is the technology behind CFAR? CFAR actually enables automated, sustainable waterborne logistics by combining the skills of remote operators with autonomous technologies. Here in this picture, you can see 3 different remote operation centers implemented by CFAR. On the lower left corner, you see our headquarters with 6 control stations in Antwerp. On the upper left side, you see the remote operation centers at our customer side. And on the right side, you see the remote operation center in Duisburg. So why are we doing remote operations? What are the advantages? We want to enable the sustainable shore-based job so that the remote operators work for 8 hours like a normal employee. They come to the office, for example, 6 in the morning until 2 o'clock, and then the next shift starts at 2 in the afternoon until 10 o'clock in the evening. We want to attract younger generation to inland shipping, and also we want to promote diversity and inclusivity. So here you can see the high-level solution overview of CFAR system. On the right side, on the lower part, you see all different sensors and devices put on the vessel, like LiDAR, global navigation satellite system receivers for positioning, night vision cameras for sailing during night hours, the inertial measurement unit, the cameras, the normal cameras for the day operations, the audio sensors, so enabling the remote operator to hear the sound of an engine and also to be able to hear the ambient sound, and also radar for having a sense on the distance information. Then on the right side, on the top side, you see the different interfaces and vehicle control system. So we enable interfacing with the different equipment on board, the original equipment on board. So enabling the remote operator to steer the vessel, having access to propeller and the thruster. And of course, we have the connectivity solutions in place to transfer all the data. So we have 4G, 5G connection, redundant connection for that, of course, and also satellite connectivity for some areas where cellular network is not fully available. So we transfer all the data to CFAR Cloud, and from there we use data for 2 purposes. One of them is, of course, showing the live data to the remote operators who are sitting at the control station and require high resolution camera streams, require low latency data, and also we use it as historical data to show the information to the regulation authorities and also third parties. So knowing that, for example, we have a permit for sailing in a specific waterway, the regulation authorities are interested to know that how did it go? Was it safe enough? Was there any specific challenge there? So in this way, we show all the necessary information to the regulation authorities. And what do we have at a control station? So we have the monitors to show the live camera streams. We show the charts and the radar to the remote operator, and we also have the coning dashboard. So similar to the one on board, but there is a key difference, which is the connectivity, because of course in remote operation, connections play a very important role. If we lose the connection, it means that the remote operator would go blind because they don't have access to the camera streams. So it is very important to know about the connection status and of course the joysticks to steer the vessel from the remote operation center. We also have the UPS in place. So in case there is electricity blackout, then the control station can continue with the operations. So situational awareness is very important for us because the remote operator, as you see in this picture, is sitting in the office area, and it's important to enable them to have a good awareness about the surrounding environment. So in the project Pioneers, we worked on a specific solution as enhanced situational awareness. So for that, we have collected data from different trajectories and trained neural networks to enable the object detection, meaning that we detect the different vessels surrounding the ego vessel, which is sailing in a waterway. And then after the detection of the vessels, we also enable the distance estimation. So we use the radar and AIS data. We use Kalman filtering based solution to fuse this data, so the sensor fusion. And then we have a sense of the distance information, meaning that we highlight the vessels upcoming from the front for the remote operator so that they have a feeling that how far they are. So if these vessels that you see are highlighted with green color get closer, the visualization would change to red color so that asking the remote operators to have more attention about these vessels so that as they are sailing for several hours, it is very important to highlight this kind of hazards for them. As we also referred to this fact that the remote operation of vessels is not the only that we have focused on in the previous years, here I would like to also show you some pictures from Lusta 5G project. So in this project, we actually applied our technology to a gantry crane, and we enabled the remote operation of this crane from an office area. So here you see operator sitting behind the control station, similar to the one that we use for the remote operation of the vessels, with some changes like the joysticks are different here, and controlling the crane, which he used to control from the control room of the crane itself. So we have actually equipped this crane with cameras, with the modem, so similar to a ship. And also we have our vehicle control system at this crane interfacing with different equipment of the crane. In the same project, we also applied our technology to a truck and enabled the remote operation of this truck as well from the same control station, showing that this technology is also applicable to the other vehicles, enabling the modal shift in long term. So to conclude this presentation, I have to say that the partnerships are the key to success as we are innovating. So the vessel owners and the skippers play an important role in investing in our solution. The technology itself helps us to automate the solution, and the government and regulation authorities facilitate all the innovations that we are doing. So the successful completion of a project actually requires the seamless collaboration between all the parties involved. The technology of CFAR is supported by various organizations, and CFAR has a proven track record of collaborating with authorities, regulators, research institutions, and also customers, driving the progress through trust, compliance, and co-creation. So, thank you so much for your attention. If you have any question, we would be happy to address that.